Welcome to Embedded, the show for people who love building gadgets. I'm Alicia White alongside Christopher White, and we are finally joined by Dennis Jackson, although I have no idea what we're going to talk about.
Hi, Dennis. It's great to have you here.
Hey, Chris. Hey, Lisa. It's great to finally show up.
Could you tell us a bit about yourself?
So I've been writing software for about 15 years, maybe actually longer. I graduated way longer than I thought. I've always worked in medical devices. I've always wanted to work on something that, basically helped people. I've now joined my first non-medical device company, but it's still a regulated company in theory. It's up at AirWhere in San Francisco, and I like writing software. So, embedded software, bigger software, small software, anything.
Web software?
No. No, not that big.
Make that clear.
We need to bound it.
Yeah. No, I enjoy writing software. Actually, I like writing software. I like flying. I like robotics. So I've always worked on software that has some kind of physical interaction with the world.
I totally agree with that, of course. And what languages do you use?
It's always been C or C++. For scripting, Perl a long time ago, but now Python. But always C and C++.
I think that may be the definition of embedded soon.
It's funny because people have these these Linux system on chips, and there's I'm doing embedded. I'm like, what are you using? They're like, I use Python, or I use Erlang, or I use
Scratch.
Yeah, everything.
I like Scratch. It's great.
I've heard of it. I haven't seen it, and everyone's saying, I do embedded software, and I use this interpreted language. I'm like, okay, that's the world we live in now. Is you can buy basically a full computer that runs on a chip, and yeah.
Well, even the Electric Imp, and there's another one that's similar that run either on JavaScript or Squirrel, which are all interpreted or semi-interpreted, where they go to a bytecode that runs on it. But yeah.
I think it's awesome because it does give more people access to it. I mean, you can run your software in something that is interacting with the physical world. And I don't want to say, hey, you're not really writing embedded software if you're not writing, all the way down at the assembly level, or you're thinking about bytecode or individual bytes.
You're not writing binary. You're not writing it properly.
We'll allow you to write in forth.
Yeah. I don't want to be an embedded snob, but I always find that when people start doing things and they're like, yeah, we need more performance out of it, they always fall back to C and C++. So it's the foundation.
So I meant to ask you, what does AirWhere do? That is your current company.
Yes. So we are working on basically a operating system for drones.
Wait a minute, we have to say that again. Drones.
Watch out. There's a drone coming. UAVs, drones.
UFOs.
That's the hot new thing. But, if you look around, they're coming. We're not aiming, not right now.
Chris flinched.
they're coming. There's the hobbyist market is really ramping up. You can go on Amazon and buy a $40, maybe even cheaper now, just a little hobbyist drone. You throw in a battery, you got a little, it actually plugs in USB, powers up, and you can take off.
Wait a minute. If they're on Amazon for $40, why was that other one so much more expensive, Christopher?
Because that one was probably way better.
It was only like $80. It was a big one.
It was
bigger.
Big, I see.
And you can. So
I also have the $40 one. It's right here.
But you can do it. I mean, you can spend from tens of dollars to hundreds of dollars to thousands of dollars on hardware. So there's the hobbyist market that's coming up, and then there's the military market, which they're all highly customized, or and they go off and blow things up.
They do monitoring too.
Yeah, originally they were for blowing things up. Now they're doing monitoring. But AirWhere is looking for everything in between. We're looking for that whole commercial market, and there's a lot of things. It is actually already big in Europe, but it'll be coming to the U.S. soon. Is agriculture, infrastructure, monitoring, all kinds of things you can use them for. That people just right now you can send someone out and go record something, go measure something, but it'd be really great if you could do it from the air. And you can do that. You can go rent the helicopter. You can go hire a pilot. You're going to pay a lot of money for it. But if you had a drone where you could load up whatever your sensors were or whatever thing you wanted to record and describe a flight plan and just take it out there, put it on the ground, hit go, it goes off, flies the whole thing. You collect all your data, you go back, you do your analysis on it, and then you say, maybe it's a farm, you want to go do it like every week. Well, getting a pilot lined up, making sure conditions are right, like that's going to be a real pain in the butt. But if you're a farmer and you have a drone that can just do it for you, you put it out there, hit the button, takes off, you get your data, and you do that every week. And now you have something, you have like a real time quote unquote control system for your farm that you are providing the feedback for that you can use to figure out what you need to do next.
Whether it's water more or take care of infestations or
Yep.
any of that, because instead of traveling 1,000 acres every week, you have something that can do that for you.
Yeah, exactly. So,
but you're not making the drones.
No. So AirWhere doesn't make any flying hardware. We make basically the brains that live in there. We make the autopilot and the modules that will you'll either plug your sensors into or that we've already provided or control your motors. So and we have some other things coming down the line as well. But we actually don't make, like, you can't call up AirWhere and say, hey, I want a quadcopter or I want a fixed wing aircraft. Like,
I want a quadcopter that will monitor the water levels on these 3 reservoirs that are 20 miles apart.
So we'll give you some people you can call and recommend, and they're using the AirWhere hardware inside. So
you're like the gyros and the IMU and the
GPS.
The GPS and all the route planning and that kind of thing.
So we have the embedded hardware. We actually have desktop software, so you can do all your flight planning, your job planning, or whatever it is that you want to do with your aircraft. And then we have a way of getting that all back into the cloud, the latest hot thing.
Oh, so do you help them take data as well?
Yep.
Well, that's pretty cool.
So there's going to be, we're building an entire infrastructure for it. So my role in it is on the embedded software that actually flies the aircraft. We actually have some
flight control.
Yes, flight controls. We actually have flight controls engineers who actually work on the flying algorithms, the control laws,
the quaternion, the Kalman, the
everything.
Super fun stuff.
Yep. And I've played with that in the past, way back in my day. But now I'm working on, myself and my team work on the all the other hardware that supports the flight group. So we work on the way I describe
synchronous sampling of the accelerometers and gyroscopes.
Sampling of the gyroscopes. We provide them the data. The way I always describe it to interview candidates who come in is the flight controls guys are the brains. My team is the nerves and the muscles. So we take all the sensor data, we provide it to them. They figure out, hey, we want to bank, we want to bank, we want to land, we want to do something, and then they say, okay, in order to do that, we have to power this motor or spin the props up or do something, and they come back and tell us, okay, go do this. So
and you do it in a safe manner that ensures that it doesn't fall from the sky, and that they didn't just say fly to the center of the earth as fast as you can.
Yes. Don't aim low.
So would FAA, there was a question, I was getting to it. Hasn't the FAA said, no, you can't do commercial stuff?
So the FAA has come out...
And doesn't the FAA rule the whole world, so this doesn't matter in Europe?
No.
Well, so the FAA has come out with what they're planning on to be the rules. They did that just a few weeks ago, and there are rules to it. I don't know all the details of them, but what they've basically said is you can fly during the daytime, line of sight. There's some other stuff in there too.
That was the annoying one, the line of sight.
The line of sight one.
AirWhere would allow you to fly non-line of sight.
It's all autonomous, yeah.
Well, I think also licensed pilot either was or was going to be one of the rules.
It was one of the rules, and they relaxed it, I believe. But
Well, it didn't make much sense because
No.
the commercial requirements were very strict. Licensed pilot, line of sight, those sorts of things. But for hobbyists flying the exact same hardware, it was do whatever you want.
Yeah, well, that's the funny rule right now is you can stick a camera on your quad, you can fly up and look over your roof, like maybe you want to look at the gutters on your roof and say, hey, look at the gutters are clogged. But it's now your neighbor says, hey, that's really cool. Can you do that for me? And I'll buy you a pizza. You're now a commercial operation. The FDA can come in and say, well, we want to shut you down. Like I was just looking at my neighbor's gutters and we're going to have pizza later. So it's still very, there needs to be more definition, and it's gonna come. It's just standard FAA doesn't operate at light speed.
Last week Amazon was granted a preliminary okay to go ahead and start trying their delivery service, subject to these rules. So it still has to be line of sight and everything.
Right.
But the FAA said, go ahead and start working on this.
And part of that was like they have to submit the type of air. Like there were a lot of restrictions on it, like the type of aircraft. Like if they go and make modifications to that aircraft, they have to get a reapproval for it.
Wow.
It's really, really strict. So it's going to change. I mean, these are all preliminary rules. It was basically get them out for comment. So all these different organizations.
And boy, were there some comments.
There were some comments. So they, it's going to be a whole process to figure out what's going on.
It must be a big additional challenge because you've worked on FDA stuff before with me.
Yes.
And, the rules were the rules. And
yeah.
They'd sometimes change every 3 years or so, but it would be not a big change. It would be sometimes relaxing of regulations.
Yes.
But we have no idea. We're writing the rules as you're making your product.
It's actually been really tough. So I started there a year ago in March, and when I started, everyone said, hey, it's a safety critical system. We're going to have all these FAA rules. So I came in with the mindset of, okay, I've worked on class 3 and class 2 medical devices, and safety critical was always like, it's been ingrained in me since I started working. Like it's the only things I've ever worked on. And so I came in and said, okay, these are all the things you have to do, like system level requirements, your hardware requirements, your software requirements, your design descriptions, your traceability, all across the entire thing. And people looked at me like just blank stares. They're like, what are you talking about? I'm like, what are you talking about? Isn't this going to be a safety critical system? And they're like, oh yeah, totally safety critical. And then
and it meant something entirely different. Didn't have to do with killing people at all.
Yeah, and so that's been one of the growing pains and transitions for me. But what it is we think without knowing exactly what the FAA is going to put on as requirements for drones, we are trying to write as safe software as possible, but we're not following there's no plan yet to say these are all the requirements that you have to meet for a safety critical system to fly in a drone aircraft. Until that comes out, it's probably going to be DO 178. It's probably going to be
have to choose a class there.
Some subset of that, but we don't know what it is yet.
Probably not A. B would still be
too high.
It might be B. It'll probably
C,
be C.
You don't really have that much documentation anymore. And
no, I think they'll make a class.
I think it'll be a new one.
B and
I think it'll be a new one.
C and a half.
Yeah,
B minus.
C minus, C plus. So as a culture, especially at AirWhere, like we keep in mind, like we test everything. We do have requirements, not to the level that I would personally like. Like for example, when I started, I was working on this one part of the software, and it's like, hey, here are the requirements, and it was like 10 requirements. I'm like, but just in the description that you gave me, like I heard 10 more. So I expanded on all of those, and things can always be made better. There's always more requirements that you can figure out. The software can always be made a little bit. You can optimize it. You can clean it up. There's always things you can do. You just have to know when to draw the line. Like this is good enough for what we're going to use it for, and it's safe. So that's been a big struggle. But the FAA side of it is we just don't know what they're going to say yet. So we're writing it to a level that like we find acceptable. And it's not just like, hey, we wrote it and it flew. We do have a lot of feedback inside. We have continuous integration testing. We have a QA group that takes it and runs it on local hardware. We have an integration group that runs it on our own systems, and they fly those. And we get feedback from everyone all the way back to the software about, okay, this was unexpected behavior, or did this, it's a bug in the software, or we would like it to do something different. So we have all that feedback loop in there.
So when they fly for testing, is that commercial flight?
So you can have, we do some stuff at AirWhere. We do some testing inside the building. So that's on our property.
I hear there's a hangar you can rent in Mountain View.
I've heard
it's
that
very
too.
large.
Yes, I've seen that one from the highway. But we have, so you can get exemptions for flying on private land. So
you should hope so.
Yeah, you can. So, I mean.
Well, but then that should cover farms.
There's probably some way.
There's probably some way.
There's probably some.
It's probably not commercial use if you're doing it
for yourself.
Like, yeah.
Yeah.
I don't know.
I
don't think
we are not lawyers. Did we mention that?
I am not a lawyer either. I write
software.
I write software. But so there's some locations we can fly, so we can take our aircraft out and test them.
Is that fun? Is that like a field trip and everybody's goofing off, or is that like a really stressful? When you used to go test on...
I haven't gone on one yet,
Oh.
so I don't know. But usually they bring back videos, and depending on how things are going, from what I hear, it can go back and forth. The first couple ones are very stressful because it's like, is everything going to work? I mean, they did all the build. They ran it without props in the building. They ran it with props inside a netted cage, and it flew. But now you're outside. You're away from all the engineers. Like,
there's wind.
Yeah, there's
uncontrolled RF.
Yeah, there's all kinds of stuff. So those ones are a little more stressful. I do know one of the locations they go, there are a lot of cows, and there's apparently one cow in particular that's really interested in their drones. So he's always coming over and like checking things out, and they have to go away.
We really should be able to make a title out of cows and drones or something here.
And one of the our integration group has said, hey, we want to make sure everyone gets out in the field at some point, but I just haven't gone yet. There's a lot to do.
Well, in field tests can feel like boondoggles interspersed with moments of terror that it's your fault, it's broken.
Yeah. It's true. I actually do want to do one because I've gone on, first in human studies before, and that's always really interesting because now you're in an operating room, and like your software is running, and there's a person on a table that is, depending on what the device is, or, you really want to have that software really good.
So let's actually explore that for a second. Not the good software part. I want to get back to that. But you mentioned FDA Experience, and I know you worked with Christopher on OCT, yes. Optical Coherence Tomography.
Yep.
Is that right?
Yes.
Good. And that's like, putting it in science fiction terms, that's a lot like the cameras. It's like a camera that can go inside your artery.
Yeah, I always describe it to people as it's like putting an X-ray machine on a catheter that you can put inside your artery, because you can see about 3 millimeters into tissue. So it's like, it's totally science fiction. It's like I'm using a laser beam to look inside your artery to see inside the tissue itself and putting it on the screen so a doctor can figure out what to do. It's pretty cool.
And one of the things they could do was to clear plaque in people's legs so that they didn't lose their legs.
Yeah.
Yes.
And you went on some of those.
Yeah, I did first in man studies in Poland and first in man studies for a different device in Paraguay.
Yeah, I was very glad to have hired you, because then you could go do those things.
Yes. Chris's aversions to flight is well known.
Yes. And so you have brought some of the FDA rigor to your work at AirWhere.
I've tried
with some success.
Yes. So so one thing that's really nice is our lead QA. She has she came from like the satellite world, and
And you don't get a lot of chances to screw that one up, do
No,
you?
and that's the thing I really like about her is that it's like you put this in and you ship it off, like it's not coming back.
We're not going to visit it.
You can't go hit the reset button. Yes. So she is very much on, regression testing, thorough testing, automated testing, so that someone checks something in, it runs on hardware. So she's put a lot, like her and the rest of the group have put in a lot of effort to make it so that we don't have to think about it. We just say, hey, we make changes and we push them, and they either pass or fail, and we get that information back.
So this may be a question you don't want to or can't answer, but do you have like a simulated flight environment so you can run the algorithms on a drone inside the computer?
Yeah, we do actually. HillSim and SilSim, hardware in the loop simulation, software in the loop simulation. We have mostly SilSim right now. We're working on the HillSim side of it, but our actual autopilot code can compile down to an application that we can run on the computer and feed in false, synthetic flight data. So here's your GPS, here's a wind coming into it, and it'll respond to it. And you can use our ground control station software to monitor the flight and tell it to take off and land. And okay, I want you to fly this route, and so we can do a lot of testing that way too of the control laws.
SilSim, software in the loop.
Yes.
Okay. And HillSim, what is the sum part? Hardware in the loop, I understand.
Simulation.
Okay. I'm just saying it wrong.
SIM, S-I-M. That was me probably misspeaking.
And so I know at ShotSpotter, we had one device that we had ripped out some of the sensors and fed in electrical signals instead of sensors. And then we would put our new code onto that hardware and have it run. And that would be hardware in the loop simulation. Because even though it's a black box at that point, right. A physical box. We also had the software in loop simulation. We called it a sandbox, but everybody has different names.
Yeah. That's the beauty of writing software, is everyone has a different name for everything. Everyone ends up saying the same thing, just differently.
And then they argue about it.
Yeah.
They argue about it. So do you fly UAVs or drones in your free time?
The first time I ever flew a UAV was on my interview at AirWhere.
Was that one of the questions? Can you fly this?
They came in at the very end. They had one of the little, like the Amazon $20 ones or something like that. You have like the controls are super fine,
and you can only fly them inside. They're too sensitive to wind.
You look at it wrong and it falls over. And so the interview went well, and they came in and I don't even remember who it was now. He came in, he said, okay, here's the final part. You got to fly this thing. And I remember being nervous because I'd never even touched one of these things before. I'm like, okay, here we go. And I picked it up, and he's like, okay, the right stick is your vertical, and then whatever. And I pushed it, and it took off. I'm like, cool. And then it just dove right into the table. And he's like, oh, that always happens. Okay, put it back up. And I got a little bit higher, and I got about, I don't know, my longest flight was probably 6 seconds.
So that wasn't a requirement for the job.
No, which is good. But I have one now. It was one of so at the holiday party, they had a whole bunch they had some drones, they had some other hardware that when they called names, you could go up and grab something. So I figured I should own one at some point. And so I took it to my in-laws' house and charged it up, and then put the props on, took off, and promptly broke one of the props because I crashed it. I put the prop guards on right after that.
Software is about writing instructions for things that we can't do, so that something else can do them.
Yeah, that's right. That's right.
So you don't have to be able to.
Yeah. But the amazing thing is, our integration team, all those guys, all the people in that team, all fly. They do it on the weekends. They do it at work. And the funny thing to me is they're working on a system that says you don't actually have to be there. We're going to make it all autonomous. But they have so much feedback to it, and there's always manual control as well. And they've brought in some videos. They go for these things called they call them fun flies on the weekend, and they just once a month they go to a field somewhere and go flying. And these guys are amazing. What they can do. I'm like, okay, you guys know what you're talking about. So I mean, the people that are working there love flying. So it's really cool.
So how small of a device does AirWhere work on?
How small of a device?
Well, you said the $20, $40 tiny indoor things.
Yeah, that's going to be too small.
Yeah.
Like our main autopilot is probably, I don't know the exact dimensions, it's probably 2.5, 3 inches by 1 inch by 1.5 inches. Sorry for anyone not on inches. It's the world I'm stuck in.
It sounds like it's about the size of one of the half-size Altoid tins, the small Altoid.
A little bit bigger than that.
Okay.
It's definitely
maybe a
taller.
full Altoid.
So it could run a fairly small craft.
Yeah.
I was thinking the DJI Phantoms, but that's actually much bigger than you need.
Yeah. I mean, most of the aircraft we have at work that it flies on are probably, 1.5 feet, 2 feet in diameter. I mean, they're most of it right now we're flying are quads. Quadcopters. So, figure, well, now it's a square, so 2 foot on the side, maybe a little less. So, I mean, it's the autopilot itself. You have the autopilot and you have some other board, like you have an actuator board, the GPS board. We've separated the components to make it a more modular system. And so you have to have room for all that. Your batteries are probably going to be the biggest constraint. So
did this sort of Altoid's tinish size include the batteries in the GPS modules, or are those additional parts?
The batteries are always... So we run off whatever the system power is. So whatever batteries you're going to fly your aircraft, we use that same power. And you could have an alternate battery in there too, but like you get the AirWhere components and you don't get a battery. Please, battery is not included. We should actually put that on the box. How do you? This is going to come out wrong, so I'll just go ahead and say it. How do you make your software lighter? I mean, fewer ones, fewer zeros. Ones are really, really heavy. Yes. But you do have to think about that, like how to make it more power efficient, how to make it run on a smaller processor that needs less. Well, that's the funny thing. It's actually really funny because I was just thinking about this the other day. When I was at Avenger, we had wall power, so. Avenger is the OCT company. Yes, Avenger is the OCT company, and we had infinite power. We just didn't care. We were plugged into the wall. And you had a big computer there. Yeah, that was quote embedded. Yes. It was a PC inside of a chassis. I worked at St. Jude Medical, and there you're running on it. Like if you're working on a pacemaker, that thing's got to run for 10 years. So there you really consider power. Like you think about every piece of power, anything that's going to use power in there. When I was at Deca Research, when I worked on the iBot, that was plugged. We were also running on batteries there. You had to plug it in every day, so it wasn't a matter of you had to run multiple days. But you did consider that. But the motors in that system was going to eat way more power than the processor ever was. So when I got the AirWhere, I was thinking, okay, we got to think about low power modes, like when we land and we don't use power that's unnecessary. And everyone's like, don't worry about the power. I was like, what? And they're like, what? The motors draw so much power. Yeah. It's a drop in the bucket. So we could spend all kinds of engineering time figuring out how to do all this stuff that doesn't matter. Don't optimize the milliwatts when you have actual watts to worry about. Now, are we going to do that long term? Like, I don't know. Like right now, we just don't even think about it. And I know our hardware guys think about it. They think about how much power the board's drawing. Like they think about it, but they have not put the requirement on us. Like, okay, when the aircraft is not flying, you got to make sure everything comes down to the lowest power mode, so we conserve milliwatts. Like we haven't even had that conversation.
I want to go back to, you asked if he flew drones on the weekends, but I know you're actually a private actual airplane pilot. Oh, right. I forgot about that.
Technically, I am not. I saw on our website, it says I am.
You're working towards it. You have experience.
I have experience. I've actually done my solos. I did my short solo. I did my long solo. I did everything except for the 3 tests that you have to do. I was trying to cram those in.
The written tests?
The written, the oral test, and the flying test. Oh. And so, I should have done the written a long time ago because I could have just knocked that out, done. I was trying to get all 3 of them done, and then, life intruded. Life intruded. My son was born, and literally like 2 or 3 weeks before my son was born, I talked to my wife and said, "Hey, I can line up a time to go fly with this guy." She's like, "No, absolutely not." I'm like, all right, yeah, that makes sense.
Yeah.
So I kind of put on hold since he's been born. I think I've flown 2 or 3 times. And I remember talking to a guy when I was taking my lessons. Like, yeah, I got 80% of the way through, and I just had to do a little bit more, and I didn't finish. I'm like, how could you not finish? I'm like, oh, that's how you don't finish. So a lot of guys, I keep saying guys as a general sense, but a lot of the folks I work with actually are pilots. I need to finish those tests.
Does that inform any of your experience there, knowing principles of flight?
It does. It helps in conversations. The stuff I'm working on right now, I'm far enough in my career that I understand like there's certain things that have to be done no matter what. Like someone has to write the software that turns the motor on and off or turns the light on and off. Like those are things that that's just things that have to work. It's not sexy. It's not the coolest thing, but these things have to work. And so I spend a lot of time working on the things that, in my group, we do all the things that have to work in order to get the aircraft in the sky. So we're not worried about, what's the angle of attack, what's the airspeed. Like we have the sensors that will tell them that, but we're like, let's make sure we get the right data. Let's make sure we get, this thing could be sitting on a desk, could be sitting in an aircraft. I don't know where it's going to run, but it's got to run correctly no matter where it is. But I mean, in terms of conversation with people, it helps a lot. Like when they start talking about, actually, I missed the brown bag lunch and learn. Our CTO talked about controls and flight controls, and I overheard someone else the next day or the week after talking about how, oh yeah, I had to look up all these terms because I just never heard them before, and he's talking about yaw and pitch compared like how they interact, and I'm like, oh yeah, I just thought everyone knew that. But I mean, it's just one of those things. Like you just assume everyone else knows all the things that you know, but not really.
It's a very engineering personality quirk. But Chris, you did used to fly. You do still fly occasionally.
Not actual things.
No, not actual things.
Yeah, not him in the aircraft.
No,
That's disallowed.
I flew RC planes for a while, and I have a couple of drones, but just little cheapy ones.
Cool.
Christmas presents.
Yeah, I when I was growing up, we had a neighbor who had flew RC planes, and I remember he'd go out there and test the engines on the block, and it was so loud. And I always wanted to go see him fly, and I never did.
Well, those were the gas ones.
Yeah, those days are gone.
Yeah,
almost nobody flies gas anymore.
Yeah, well, now I'm dating myself, yeah. So I never actually got to go see him fly, and I never got to fly him. So now I work at a company that does it all. So it all comes around.
Although when we talk about delivery, and Chris mentioned Amazon, everybody looks at it as like the next super freakishly popular thing, but
that's the way it looks like it's going right now. Like every day I see an article on drones.
I know, but between safety concerns and just pure energy efficiency, I'm not sure I buy it. As a data collection system, unbeaten, just absolutely phenomenal. But as a delivery system,
that I don't know yet. I mean, the hardest thing on all of this is power. It's exactly like your phone, like anything that's not plugged into a wall. The limiting factor is always power. And with a drone, like you can get more power on it by putting more batteries. But now you need more power to fly it. So it's the same thing. Now you're going to start saying, "Oh, I'm going to put cargo on this and fly it." Like, is Amazon going to deliver
a gallon of milk? Is going to take a pretty darn big plane.
Yeah,
I doubt they're going to start with groceries
or books. The thing that they started.
They already delivered
books.
That problem. They just deliver those.
Well, that's true.
So I don't know. I mean, in terms of other things drones are going to be used for, I mean, they're already doing it a lot in Europe, where they do infrastructure. Actually, one that I didn't know about until recently, there's a company that does mine inspections, open mine inspections. So what they do is they fly over every day. They use LiDAR. They measure it. And they say, this is how much was mined today. And then they go out the next day and do it again. Like, this is how much was mined today. And it just, you calculate the volume of it. you subtract it from the previous day. This is how much you took out of the ground. I was like,
Amazing.
that makes complete sense.
This
Like,
totally does.
At the night, at the end of the day, okay, go fly over and give us the measurements. I mean, it's just like, oh, I never thought of that.
Yeah, I think there's going to be just tons of applications that people haven't even considered yet that are like that.
Yeah. And I mean, and that's so, I mean, a little plug for AirWhere, but that's where I said it before, like we're going for that commercial, like there's the hobbyist, there's DJI, and there's some other ones too. And then there's the military side, but there's this whole thing in the middle that no one's really going after right now. And actually there probably are, we just haven't heard of them yet. But what AirWare is trying to do is put ourselves in there so that everyone's using our stuff. And going back to
this is a hard problem to solve.
Yeah,
I mean, I've done
yeah.
inertial systems and
it's,
even inertial GPS fusion, and yet we still didn't control anything. We only displayed like
this
roll,
is
pitch,
where
and yaw.
this is where you are, and this is how your
Orientation.
orientation is. Now you got to control it. But going back to the FAA, what we see is the FAA is not going to want 1,000 different vendors doing aircraft. They're going to want a few, and they're going to want a few people saying, ideally they want one, and which happens to be called AirWhere. But there's some options involved. But I mean, it's the same thing with the FDA, the FAA. Like, it's people like always are like, oh, regulation is bad, but regulation makes things easy for them because they have to certify these things. They have to. I mean, we're not sure what the FAA is going to say on drones yet, but there's going to be some kind of certification. Just what level it is, we don't know. But they have to. They're going to have to certify that whatever's running that aircraft in whatever way you want to use it. If there are 1,000 different vendors, that's 1,000 different things they have to certify. Now, if you have to pay for certification, that's a great thing. But then if something goes wrong, they have to track it down. They have to be involved in everything. So if there's a few vendors, it makes their lives a whole lot easier.
And this is why there are only a few major aircraft vendors.
Yeah, exactly. Like
it's just too hard to go out alone.
Yeah.
And they do have companies that feed into them, but even the smaller companies often will work with the larger ones to get the certification because it's just really hard to do on your own.
Yeah.
So moving along from drones, unless you have more you'd like to add.
Let's move on.
What is important to know about writing mission critical software in general? And not really in theory, but more, say somebody's graduating from college. How do they figure out what's important to know?
I have a whole list of articles that I always give to people.
Excuse me, I need to start typing then.
And I'll send them to you too. It's articles I've collected over the years, and I wish I could remember. Like, there's like a few simple rules. Don't be clever is a big one. No, seriously,
No, that is.
Don't be clever. Like, I tell this to my team all the time. Like, I'm a simple guy. I like simple code. I want to sit down. I want to just look through it and understand it. I don't want to have to go jump through all kinds of hoops to fully figure out what's going on with something. Like, I want you to be able to explain it to me like over lunch or like in a few minute conversation. Now, it doesn't mean like obviously I'm versed in the subject. So you don't have to explain to me like this is what a compiler is and this is what a data structure is. Like, I understand those things. But like in terms of the solution space that we're looking at, which I can't believe I just said that, but like it has to make sense for that. And when you do something that's clever, it's like when you're like, oh, this was really neat. I did this one way that like I figured out this way to do something. Like I flip bits around. I'm like, that's just asking for trouble. Like, because you're going to be working on you know it right now because you just did it. It's in your head. And now you're going to go work on something else and someone else has to come along and maintain that. Are they going to get it right away? Are they going to look at it and say, oh, that's really weird. Like, why did they shift these things? Like, why did they shift these bits this way, do this math and push them right back? Like, unless it's really, really well documented, they're going to say, well, that's kind of weird. And hopefully there's a unit test. At my companies, there's going to be a unit test so they can see if they broke it. But if the next guy coming along, and the next guy might be you in 6 months when you've gone off and done something else, and you come back and look at your code and you're like, who wrote this? And you're like, crap, I wrote this.
We've been there.
I've been there so many times. When you do clever things, when you make things complicated, you just make more work for yourself or whoever comes after you down the line.
There should at least be good justification.
Yeah.
Because one could say that a Kalman filter is pretty clever. And that's a very sophisticated piece of machinery. But it's a thing that was developed over years with research. And you know, it's a thing.
And you can explain it.
Yeah, and you can explain it. But saying, well, I invented my own filter and it works twice as fast and does this, and nobody else in the company has any clue how you did that. Yeah. Or even if it's right.
Yeah, yeah. Actually, it reminds me of one of your recent podcasts where they're talking about, do you write your own operating system or not, your own real-time operating system or not? I'm like, why would you do that? There are so many to choose from. Like, the hard thing is choosing the one that you want to use. But like, yeah, it's a cool project to do. And anyway, so my background is actually physics. I studied computer science as my minor. All my teachers, all my physics professors thought I was actually a computer science person taking physics classes. And when I graduated,
that turned out to be true, didn't it?
It actually did. When I graduated with a physics degree, and they were like, "Whoa!" But
who are you?
Like, "Whoa, welcome to the department." I was always in the department, but I was always writing software. But I forget where I was going with this.
Well, let me interject a story here.
Damn.
While you think, because it's related to the "don't be clever." It reminded me of when I learned to drive. My stepdad was a professional truck driver. And so even though he did not teach me how to drive, when I was learning, I asked him, okay, there are all these rules and I'm learning. What is the most important thing for me to do? And I was such a klutz. I expected him to say, don't trip over your feet or something along those lines. And he said, don't be clever. He said, you're a smart girl. And you can optimize all of the paths and you can figure out how to do all of this. But the thing you need to do is to be as predictable as possible.
Yes. Predictability is really important in anything.
I think that actually, and it really, I started looking at what I was thinking about driving and how other people drove. And it was important because that is what I do now. The reason I indicate changed lanes is because then I'm predictable, and it's not about being a jerk. It's about letting other people understand what's happening. And maybe that is a good software idea too, is to not be clever, to be predictable, to do simple things.
Yeah. It's really about making it so the next, I say this to my team all the time, just be nice to the person that comes after you.
Yeah, we had a show. You asked me for a couple of shows you'd like, and you probably would like the one with Chris Sveck from last fall, where we talked about empathy-driven development. And the idea is you don't treat your coworkers like they're stupid.
Yeah.
And because it is going to be you next.
Yeah.
You had some other ideas about simple software. Can you share some?
Sure. So, it really comes all the way back to what you learn in school. Like, a module should do one thing. A function should do one thing. Functions should be short. All these things everyone knows because they learned it in school. Is this when you start getting in the real world, the real world always intrudes. Like, okay, this function does this, goes off and reads this sensor, but it's got to do some processing of it too, and maybe it's got to average it. So let me add these other some helper bits in here and do some more work. And all of a sudden now this function has gotten really large, and it's going to be hard. It's harder to maintain. And actually, going back to talking about, we haven't talked about it yet, but we talked about it earlier about test-driven design. The nice thing about that is I think it helps you write better code, from the fact that since you always have to test your code, you're always thinking about, if I add this little bit in here, if I add this for loop or this if statement or this, some kind of branching mechanism, how am I going to check all the different possibilities? So going back, like keeping it simple, like a function does the thing it needs to do. If you're using C++, the class does the thing it needs to do. You're not you're not trying to cram everything into one file so that you don't have to worry about, okay, I have to look in this file, I have to look in this file. It's like, break it down so that the thing is easy to understand and easy to test.
It's a tall order, though. I mean, you end up with, so you think, okay, I don't want it to be complex, so I'm going to put it all in one file. But then I don't want it to be complex, so I'm going to put it in 10 files.
That's all about trade-offs.
Yeah. And I think you and I and Chris are all on the same page that there isn't a single right way.
Yeah. And that's I think one thing you learn I've learned as I've gotten older and seen more software is that there is no one right way. Everyone does something slightly different. And it's just a matter of learning to adapt to what your coworkers are doing and coming to a consensus. That's one thing I think about my team is really great is that, we'll go into a room and say, this is the way I want to do something. And the other people on the team will say, I think that's great. Or someone else will say, I really don't like that because of some esoteric reason. But we don't come out of the room fighting and yelling. We're like, what does the group decide? Okay, we're gonna put the semicolon, or we're gonna put the opening curly bracket on the line instead of after the line. Okay, I don't like that, but you do. Everyone else seems to like it. Let's just go. Like, we're not here to argue over minor little details. Like
Religious wars.
Yeah, religious wars just have no place.
Curly braces must go here, and they must have a space after and a space before.
They're supposed to have spaces, and they're supposed to be on the next line.
So sick of that.
The one thing that I cannot abide is the space after parentheses and before the parentheses. I find that.
Well,
What?
no, that's I love that.
That's a that's when you have if.
That's our Avenger days
if
coming back
X,
together.
and you have to put a space.
If IF paren space a space equal space one paren space paren. So I love white space. I love horizontal white space. I love vertical white space. Some other people don't. And the curly bracket goes on the next line.
That's just wrong.
But so the style is different, a little bit different at AirWhere. We have lots of horizontal space, not so much vertical space. That's my next project.
Is it? I mean, are coding standards worth it? I know in medical products and in FAA, you have to have a coding standard. Some people use it as an opportunity to specify curly brace location, but you don't have to.
No, I've almost every coding standard I've seen says it somewhere in there, like where certain things are going to go.
I don't think it's as important as people think it is. I don't need the code to be that uniform. I'd rather it was simple than uniform.
So I think coding standards are important so that people write their code in a similar way. Like in terms of formatting, there's tools for that. I get so I am guilty of when I'm doing code reviews. Like I see spelling errors, I call them out.
Yeah,
because I can't help it. I read so much. I've read so much my entire life, like from a kid on, like spelling error. And I make spelling mistakes. And I love when people call me out on them because I'm like, damn, how did I miss that? But I a lot of times I'll call out a spelling error, but I'll let them go by until I find an actual error. And once I find an error, then I'm going to call all your spelling errors out because like you're already going to go edit that file, so might as well fix all this other little stuff too. But like formatting stuff, there's tools for that. Let's not argue over that. When I see people in code reviews are like, hey, your curly bracket's in the wrong space, I'm like, okay, thanks for wasting all of our time when we have a tool that does that for us. But I think coding standards are important from the point of how you name things, how you like are you like if you're doing C++, like how many things can you inherit from, or can you use templates, or what scope can you use templates, and things about the language. Like we do not, like on an embedded system, especially on a safety critical system, you can't use malloc. You can't use dynamic memory. And if your tool supports the way to verify that you're not using any dynamic memory, you should definitely turn it on. Because it's really easy to slip that in, and that can cause all kinds of issues. So I think coding standards are important from that point of view, but getting down in the nitty gritty about even on spacing.
You do know I'm just giving you a hard time.
I know. I've worked with you long enough to know this. And that's why I still talk with you. I like you. You're on my list too.
This is on tape now.
I know. And the fact that you're on my list is on tape too. And the fact that I have a list.
At lunch, we were talking about lists of people we would like to work with again, or people we'd like to poach and all make a company that would be great. And that we collect these sort of lists of people, and maybe it doesn't go anywhere, but you're on my list is not a bad thing.
I have two lists. You're on the good list. I have a bad list too. That list is very short, fortunately.
Mine is too.
The bad list?
I do have a few people I would never work with again. That if I found out they were at a company I was going to, I would just say, "Oh, thank you, bye."
Yeah.
But it isn't a very long list. It's
Well, and you can shorten that list.
what?
The bad list?
Yeah,
I'm not
take
killing
care of those
people.
That's on record. That's recorded now too. But back to like coding standards, like I think it's important to have something in place so people just have an idea. But the rule I always tell my team, and I always try and follow myself, though sometimes I impose my rules a little bit on other people. But when some people like leave a company and then they come back as a contractor, I get to impose the rules.
That's true.
Is write like what you see. So if you go into a file like that hasn't been touched, unless you're gonna like change the entire thing to the new format or like naming conventions or whatever, write like it is. Like don't make your code stand out from everything else.
I had a client recently who gave me a pretty detailed, and it was a fine coding standard. But then I said, you also wanted me to use this other code, and it looks nothing like what your standard says. Do you want to pay me to translate, or do you want me to match their style? Because I don't think I should put your style in what I change in theirs. And they came back with, you should match the surrounding style. That's the highest importance in coding standards.
Yeah. Consistency is far, far more important than specifics.
Yeah. And then if I'm working in a file that came from a vendor, and we're keeping it in the same style, like I usually demote it or mark it up with edited by at AirWhere or something to say, hey, yeah, this looks exactly like the rest of the file, but I mean I know or your revision control tool will tell you who wrote it. But when you're reading a file, like you're just going through, like trying to figure out why something's working or not working, you're not going through the repository saying, who wrote this? Was this written by someone at the person that sits right next to me that I can go ask them, or is this somebody at a company I'm never going to meet? So I like to leave a little tag saying, hey, we did this, just so we know. If
you're modifying a vendor file in like 6 spots or some small number of spots, I like to have those because then when the vendor updates their files, you can copy it.
Yes, yeah.
And it's not just about, version control. It's if you XXX vendor company modification here, it makes life so much easier later. That's an empathy-driven development thing.
Yeah, I mean, we create patches too, but will they ever apply again? Who knows? So
they'll never be perfect.
Yeah, having that tag there says...
And why you made that change there.
Yeah.
So do you measure code complexity? I mean, we talk about simple, but the opposite's complex. Do you have measurements?
So we technically do, and I looked at them early on, and I haven't looked at them in months.
Do you remember anything about them?
No.
That's fine. At Park, they introduced me to that as a concept that they were desperately trying to simplify the complexity of their system. And one of the takeaways was they were building an API. Mm-hmm. And they looked at the number of different words in their API.
Like when you write a story and it tells you the complexity, like the reading level of the story?
It was sort of like that.
Okay.
I mean, they had different complexity measures, but that was the one that really stuck with me. That, if they were going to use, say, sent, they only used the word sent and not transceived, not anything else.
Oh, yeah.
It was always very, very consistent. And then they started looking at verbs and nouns and other words and really trying to make it all very simple when you're learning this API, you don't have to learn 97 different ways to do it.
Yeah.
Once you see packet sent. You know what packet means because it can only ever mean one thing. It means the header's on there. It means the tail's on there.
Yeah.
And if it didn't have those, it would be called something else.
Yeah.
I really liked that, but I haven't come across other stuff like that. I guess I should ask the park guys to be back on.
I mean, so as you were talking, I remember like cyclometric complexity.
Yes, that was another thing they were talking about.
Yeah, that's the one we used to get it reported when I was at St. Jude Medical, the tooling that we use there. Tooling that we use here at AirWhere does report it. And I remember looking at it when I first started, and then it was one of those things I realized no one else was. And like it just wasn't. We're not at the phase right now where that's as important.
So cyclomatic complexity, according to Wikipedia, has to do with the number of branches you have.
Yes.
You want each function to have a single path through, maybe two paths through, but you don't want if this, else, if, until you have 27 paths you might be going through, because that's really hard to test.
Yeah.
It's hard to write a unit test for.
Yes. And it's always interesting in an embedded system because inevitably you have some kind of message handler, which is going to have some huge switch statement in it or some other way of saying, checking out the ID of the message come in and it goes off to different handlers. And that thing always grows. So, you can have the rest of your system down to, 1 and 2, your cyclomatic complexity measurement, very small numbers. And then you have this one function that has like 50. And you're like, what is that? Like, oh, that's the message handler.
Yeah. And the only way around that is to have a state machine and have state dependent message handlers.
Which adds different kind of complexity.
No, you put those all in a table, in a variable.
And then the tool can't see it.
And then it's a for statement. And then the tool can't see it at all.
There's ways around it. But,
you can totally cheat.
Yeah. I mean, but with any tool, anything that you're measuring, you can always game the system, but it's not about like...
It's better off to go ahead and say, it's a switch statement, it's a message parser.
It's complicated, and this is why.
And that's okay.
And this is how we're going to test it. Yeah. Like, when you meet a lot of people who are like, these are the rules, we have to follow them exactly. Where in reality is like, we follow them the best we can, and where there's exceptions, you write, this is an exception to the rule, and this is why we're taking the exception.
Even when you have to deal with complex things like quaternions and Kalman filters, you try to have this is not that simple. Here, go read this page, go read this book, and it will give you the basis you need to make it so that this code that I've tried to make as obvious and simple as possible. I can't explain it to a third grader. I can't explain it to somebody who doesn't have this background.
Yeah.
But once you have this background, it won't be too complicated.
Yeah, and it goes back to what we were saying earlier about, when you describe your code to me, understand that I also, I understand the system we're working on. Now, if I go, I did controls work 15 years ago. I understand control loops. I understand filtering. There's things I now, a lot of these things are on words to me, but I have some background in them. So I'm not going to go sit down and write the controllers for our aircraft. There's no way. It's not going to happen. But if they start talking to me about it, I'm like, I'm going to be rusty. I'm like, okay, I asked the right questions, and okay, I got a good enough understanding to understand it. But I'm not going to go do a critical review of the controllers. They're going to do that amongst themselves because they're the experts in it. But they can explain it to me in a way that I can understand, that I can implement software around it. So it's knowing your audience, and when I say simple software, it's simple for the audience that it's going to be for.
And you do need that caveat.
Oh, I remember the operating system one.
Okay.
It was, what would you write your own operating system or not? And it comes down to we can write our own thing here, but what's your core business? Is your core business going to be writing operating system, or is your core business going to be, I don't know, making an autopilot? That being said, we're not writing our own operating system. But I hear this conversation a lot, not just, I've heard it either, when I've read things online, when I've been at companies I've been should we write our own code that does this? I'm like, does someone already do this? Are they much better at it than us? Let's just buy it.
It's tough. I mean, our tosses in particular can be hideously expensive, although last week's was free, which was really amazing.
Yes.
But it is, I had this experience. I interviewed at ShotSpotter, making the gunshot location system, which is such a cool idea. And when I interviewed, I made fun of a previous company that I had stayed at for only a few weeks because they were writing their own GPS parser and they were writing their own software-defined radio. And neither one of those things had anything to do with what they were making.
Yeah.
And I didn't understand why they were writing them. I thought they should just buy them off the shelf and not discuss it. When we talk about, after it's shipped and we talk about cost reduction, we can talk about redoing those parts or expanding our business.
Yeah.
And as I was, spouting off, pretty much ranting just like this, during the interview with like 4 people, because it was one of those group parts of the interview, and the room got quiet. I mean, there were crickets.
Like, we're writing our own.
And later, after I had gotten hired, one of the guys told me that they had, with that interview conversation, stopped talking about doing their own radios.
That's awesome.
And just went for buying them. They just stopped discussion.
Yeah.
I think it's a bigger problem with smaller companies and startups where you get a
You
small
don't have
group.
any money.
Well, that's one issue, but you also get a small group of maybe 5 or 6 really smart people.
Yeah.
And now they feel free.
Yeah.
They feel like they have a lot of power.
Yeah.
And so it's like, well, hey, I've always wanted to make my own 2D graphics library.
Yeah.
Let's do that instead of looking and buying another one.
I'm sure I can do it better.
Yeah, and no, I totally understand. There's so many things. I'm like, it'd be so fun to write this thing, but that's actually not really what I want to. I think what happens a lot of times is people say, I can do this and I can do it in a very short amount of time, but they don't understand that you have to maintain that forever.
Yeah.
And it's like, I can.
It's a product.
It's a product at that point, and you're
An
now
internal product, which means they know where you sit.
They know where you sit, and you're going to be the expert on it. And if something goes wrong, you have to fix it. It's not a matter of, it's not even about blaming a vendor. It's like you have now in addition to all the other stuff that you have to do, you have to maintain this other thing. Like when I was at Avenger, we're like, hey, we want to do something with PDFs, and you can go download the PDF spec and you can do all this stuff for rendering it, or you can go spend a couple $1,000s, buy a license from whoever I bought it from and plug it in, and hey, you asked for PDFs yesterday and now they're in the system. Done.
And it's a cost benefit analysis that people don't run too.
Yeah,
it's like, oh, we have the in-house talent, so we should be able to write this ourselves, and it's free.
Yeah, free.
It's free times, it's free plus all of the money that you're paying those developers to do that instead of make the thing that your job is
The
to make.
opportunity cost, the maintenance cost.
And nobody does that and says, oh, $2,000, that's, whatever, 3 days of, a small team.
Yeah.
Versus, and like you said, instantly having it and you're done and you've got somebody who's supporting you.
Yeah. And there's always integration issues. There's always like, okay, their software works a little bit differently than exactly the way we want it. But you know what? You can probably adapt to it.
Make versus buy. If you're small enough, everybody feels like they should be making it all, but what they really should be doing is buying as much as they can.
Yeah.
In support of shipping their idea.
Yeah.
And I think that was one of the things that when Chris introduced us, it was like, oh yeah, this is a guy who shipped things, and that's it's kind of a checkbox.
Yeah.
We were talking at lunch about your transitioning into a management role.
Yes.
And my question was, have you
transitioning to a place where I end up a lot?
Yeah.
It either says I'm not a good software developer or I have some decent people skills.
Well, and project management and all of the other, but
Yeah.
I said, have you written performance reviews? And you said, not yet, but soon. I'm like,
Well, not yet at this company.
We'll give you the manager title when we'll check that box off. And then when you've laid somebody off or you've fired them, then we'll check that off another box. And it's like, have you shipped things is one of those boxes that for me makes it's a little more comfortable. You know that projects don't end when you push the release button.
Yeah. Yeah.
If
Everyone's
only.
excited about shipping, and I'm like, that's when it gets harder.
Yes.
Now you have customers, and if they don't like something, then you have to deal with it.
And it's super
it's
important.
really nice when it's still inside in-house.
So do I get a big checkbox for have you shipped things that the president wears?
Christopher's new product, the one he worked on with Fitbit, it ended up in the news on President Obama's wrist. So,
And he put it on himself. We didn't shoot it at him, and it attached to
it wasn't
Can
just
you
stuck
say
on.
shoot at the president? And,
I didn't say shoot at the president. I said shoot at him.
but you were talking about the president, so the pronoun.
And I was talking about shooting a watch at low velocity.
Yeah. Anyway,
President Clinton
Obama's-
stood next to the iBot when it was balancing. That was pretty cool. I don't know if he ever wrote it, but
But yes, it's been seen multiple times on his wrist.
that's awesome.
It must have
It's
gotten
really kind of
stuck.
cool.
So actually, we were talking earlier about medical devices and now AirWhere FAA devices. Like everything I've ever worked on has been a medical device, and everything I've ever worked on is something I don't want any of my friends or family to ever have to use.
Yeah.
So this is actually really cool about working at AirWhere. It's like it's the first thing I was like, I want people to use this. And if they say, "Yeah, use your stuff," I'm like, "Oh, that's awesome." But like before, it was like, "Hey, I have your pacemaker implanted in me." I'm like, "I'm sorry." or the Avenger was pretty cool because I mean, yeah, that was a medical device and it saved people's legs. So it was like, hey, I didn't have to get my leg amputated. I'm like, well, that's really cool. But
And it is really cool. And yet you're still like, oh, sorry you had to have surgery.
yeah. But so I'm really excited about when AirWhere eventually launches something that we people are using it, and we have like little stickers that say maybe there's a powered by AirWhere on there, and or something. That hopefully there's a way of knowing it. Actually, back to the operating system one. That's the one that's most fresh in my mind. Is Joel? Was his name Joel? Joel from Artem said, you asked him like, there's no way to know what operating system is running inside something. So maybe they should have stickers.
Well, actually,
Powered by Artems.
I'm sort of glad you brought that up because I forgot to do the Element 14 header, so I'll just stick in the commercial now. That's sort of what I wrote about for Joel, was how hard it would be to work on applications that weren't nifty and cool, and how difficult it would be to not be able to see your stuff in other things that were nifty and cool. In the episode before, we talked to Lane of Osh Park, and he said one of the reasons he did these brilliantly purple boards is so that he could see them when he walked
inside.
up. Yeah. I mean, other people's projects, he's like, oh, I had a little hand in that. And Joel doesn't get as much of that.
Yeah.
But he did get a Mars Curiosity mug, so that's kind of cool. So I think we're almost out of time, but I have just another couple quick questions.
Sure.
You mentioned unit testing, and I am a proponent of unit testing, and I often do it, but I don't do it all the time. How do you manage to help everybody understand the importance? How do you make the time? What do you use for framework? How do you get started? What's unit testing in embedded systems?
Make it so we're better unit testers.
Yes, please.
So I will be first to admit, I learned unit testing when I was at DECA, and I use the same style I use it there.
And so that was like your first job.
That was my first job, yeah.
Yeah, I always fear that it's something you have to get right away.
Yeah, and well, so like I said, I'm the first to admit that given the ability to not unit test something, it's very easy for me to fall back into that trap. Because it's like, I wrote it, I tested it, yeah, it works.
I tested it once.
Yeah, and I'm very thorough. I try and be very thorough. That's why it's really good to have a good, solid QA guy behind you.
Yes. Or sitting next to you.
Sitting next to you, yeah. But what we do at AirWhere is like your code's not done until it has all the test coverage. Like it's part of the whole process. It's not a matter of I developed this module and it's now in there and I'll get to the testing later. It's like as you commit it, like the review says, okay, where's the testing that goes along with it? And we did the same thing at DECA. Testing was a deliverable. Like it wasn't done until you had that, and also documentation. We're not at that point yet. But it's really setting up the infrastructure, setting up the like CPPU test. That's what we use.
And that's the same framework that James Grunning has in his test-driven development in Embedded C.
Yeah. So actually, after listening to that podcast, I knew that someone had that book. Our QA person had that on her desk at work. I went in the next day and said, "I need to borrow this." And I went home and read it. And now everyone on my team has read it now too. So the testing on the embedded system side, we do testing on our actual local processor, like on our PCs. We run all our unit tests there, and then we do what we call functional tests on the embedded software, where we have the framework as part of it, and we run the test and verify that the test still passed. We're not running. So when I was at DECA, we actually ran the exact same unit test on the hardware, and here we're running a slightly different variation on it, and I don't know which way is better yet. Maybe neither one of them is better, but I do know for all the errors, all the bugs that have been filed against our system, we don't have that many on anything that my team has touched. So
That's gratifying.
Yeah, it is. And now, you could argue our boards are a lot simpler than the other boards in the system, but we're also maintaining more boards. So,
did AirWhere have unit tests before you got there?
Yes. So it wasn't. That was actually one thing that was really nice coming in. Like the framework was already in, the continuous integration server was already running, and it was all part of the whole process. Now, listening to the podcast about TDD and reading the book, it was really interesting to learn how to do drivers. I haven't done it myself yet. We were talking earlier about tech lead versus manager. I lead a team. I also still write a lot of software. But like just yesterday, I was updating some software, and I was like, okay, I go in to fix a test. I'm like, okay, how do I do this again? Like, what are the pieces? Like, I'm just really rusty, and it hasn't been that long. It's only, it's been a couple months since I've worked on that one little piece, but it goes really quickly. But one guy on my team read the book and was like, wow, this is amazing. I'm going to do all this for all of our drivers from here on out. And he's just been doing it. And like, it's just, if you don't find anything, it's not a problem. But now if anyone goes and changes that and breaks it, like we know right away. It's fantastic. He soaked it right up, and he took it right to heart. It's really awesome. And he's not someone like who's just right out of school and like, okay, I have to learn everything that's possibly new and apply everything new. Like he's been developing for a number of years and said, wow, I just never knew about this. And now that I see it, I see why it's better, and I will do it. So he's much better than me because I will very easily like put something together. I'm like, yeah, it works.
I think what you said was important too. It's having the infrastructure and making it easy to do.
Easy.
So that you don't feel like, I have to figure out this with CPPU test and do this, and I'll have to put it in a script, which is a pain in the neck. I have to do something by hand. Yep. If it's just, okay, I write this piece of code that goes along with my code, it goes here and it integrates in the system, and then the server takes care of running it and verifying. That's great. I mean, because if you can reduce friction out of the things that are tedious and a little bit boring sounding, on the face of it, it'll be more likely that people use it. Yeah,
and making it simple to run too. It's like, you want to build the application, make. You want to make the test, make test. Like it has to be there. You can't go through a whole lot of hoops in order to do it. Like it just has to be really simple.
Well, that was one of the things Granny in his book was trying to do, was to make the framework simpler. Yeah, it's tough to set up, but once it's set up, the idea is that it's not very tough to use.
Yeah.
So, well, cool. I will let James know that you're using it. I think he'd be quite pleased.
I think he would. I hope he is, because we're all excited about it.
That is very cool. That is very cool. So do you have any last thoughts you'd like to leave us with?
Standard, leave the world a better place than you found it.
Oh, Boy Scouts.
It's the same thing with code. Make it look consistent, and just try and clean it up as you go along. Make it nicer.
Is AirWhere still hiring?
Yes, we are. Am I hiring? Yes, I am.
What are you hiring for?
I'm specifically hiring for an embedded software engineer.
There may be a few who listen to this show.
Hopefully. We actually are hiring when in Silicon Valley, in the Bay Area, when people say we have a full stack, they're usually talking about a Linux system, a database, some web interface. Well, AirWhere, we have the full stack. We have hardware engineers all the way up to people writing web stuff, and we have everything in between. And we're hiring across the board.
And so, do people email you? Do they email me for an intro? Do you have You can email me. We actually have recruiters. Actually, if you email me and it comes through embedded from the podcast, then I'll put a little star on it. Okay. So go ahead and email show@embedded.fm, and we'll pass it along to Dennis and let us know that that's why you're emailing it. Or, of course, you can hit the contact link, and I will just introduce you to Dennis. That'll work too. My guest has been Dennis Jackson, embedded software tech lead at AirWhere. I'm happy he finally agreed to be on the show, as he's been a friend to Chris and me for years. He was the first person to send me a picture of his kid reading my book, and it made my day.
Who was 6 months old at the time?
It might have been staged. If you have a physical copy of my book and can send a picture along, it would make me smile. show@embedded.fm will let you attach the picture, but you can hit the contact link if you want stickers or just to say hello. Thank you for listening, and thank you to Christopher White for co-hosting and producing, and for introducing me to Dennis.
Well, thank you for having me on.
And a final thought for this week. Let's go with Shakespeare. A fool thinks himself to be wise, but a wise man knows himself to be a fool. God knows all my software makes me feel like that. So we turned off the mics and we talked about our show title. But and Dennis and Chris and I always have a lot to talk about. One of the things that I did wanted to get on the mics was about maker stuff.
This is going to be a short segment.
You don't do any extracurricular.
No, I read a lot. So yeah, I don't go home and I don't build anything at home. I don't write software at home.
You do still have a small child.
I do have a small child,
but even before him,
and he doesn't write software.
He doesn't write software yet. Although my wife's an electrical engineer, so he could have a hardware side on him. He's definitely going to be an engineer, though. Like you see him checking out tires or looking at how things work. He's also got a little bit of an OCD tendency. Like things have to be lined up right. So we're a little nervous about that, but not too nervous. But yeah, even before he came along, I didn't. I think I've done a little bit of scripting at home, like maybe to do something on my machine. I can't remember. The last thing I remember writing was something to synchronize iTunes playing on two different computers. This was before like Apple came out with their AirPlay and their remote speakers, like a couple of years before that. So we were having a party and we wanted music playing on both ends of the house. And we didn't have anything wired between them. The only way I could do it was like this. And then there was just enough of a phase change between them. We're like, never mind, we turn it off. But I mean, I just don't write software at home. I write a lot of software at work, but I read a lot. Like I read blogs, I read
technical
mostly
stuff, fiction, nonfiction.
Both. I mean, the fiction. I read a lot. I used to read a lot of science fiction. Like I go on vacation, I usually read a couple novels. So,
but this has always been true. You've never, even when you were out of college, it was work at work, and then technology is.
Yeah, I mean, I read technical blogs when I'm when I was commuting down the peninsula, I'd read them on the train. Now, like sometimes also, my son wakes up usually around 7. I unfortunately wake up usually around 6 or 6:30. I think I've reached that age in life where I just start waking up early. And so that's when
you're not that old. I know because I know you're younger than I am.
Only by a little bit.
Yeah, like a month.
Yes.
Yeah, you two youngsters.
Well, you're like 8 months older.
Right.
But so I mean, I read about stuff. I read about software development. I read about best practices. I just read.
So it's interesting because we have the podcast and we're more hooked into the maker community than we used to be. And
a lot more.
I feel a certain amount of pressure to do technology stuff outside of work. And it's a little weird for me because I'm a contractor, so my hours are strange.
Yeah.
And I'm never sure when I'm working or when I'm not working. But you do feel that pressure that other people are doing these amazing things outside of their day jobs. And so, I don't know what to make of that exactly. And I'm not sure if that's necessary to make you a better engineer because you do home projects or don't.
So, I mean, for anyone who's going to be sending me, happens to send in resumes, like if you're fresh out of school or only have a couple of years experience, as I'm looking at resumes and talking to people, I really like seeing that experience. Like either
the home projects?
Yeah, or like projects that you did in school that you really owned. Like not like I had to do this thing because it was like
I was on a team with 6 people.
Yeah, like
those are not as good.
if you led that team or if you were a major contributor, that's good. But I want to see that you're trying to learn the things that you don't have that experience because you were in school, that you're going to get in the first few years that you work. Now, if you're coming in as a senior developer and like you say, yeah, I don't work on home projects, I'm like, okay, that's cool because I don't either. But you have a lot of product history and you've shipped products and you've done all this work and like you can talk about it and you can point to things like, yeah, I have code in there or I have hardware in there. Like, we're still going to do a coding test because I want to make sure you can still do it. But I'm not going to hold that against you. Like, where's that transition from like I want to see home projects to not home projects? I don't know. I never
About year 3?
3-4 years in probably. And I work with guys I work with folks that they go home and they work on projects there. The thing is, like, I really like to focus my energy on making the place I work the best place I can work, the software the best I can make it. Like, I think about our build system, I think about our tooling, I think about all these things because it's funny because I actually don't want to think. There's that book, Don't Make Me Think. I read that one years ago, and it's about user interface design. But I actually apply that, and again, I tell my team this all the time. Like, when I use our tools, when I use our software, I don't want to think about it. I don't want to have to think I have to do this esoteric command in order to do something. I want to hit 1 or 2 keys, and I want it to work.
Yeah, think ahead of time so you don't have to think later.
Yeah. And
think once and think thoroughly.
Yeah,
and then just sleepwalk.
I come back from vacation, a vacation. I don't have to relearn how to do all this stuff. I just says, oh yeah, I hit this thing and it works. Like, just don't make me think. There's all these things I have to think about already. Don't make me think about more things.
I wanted to record this part because at least one person thinks that when I get done with my day at contracting, I go into the lab and start tinkering. And that's not true. I do. I mean, I have this thing here that Dennis can see, and it's got wires coming out of it, sparkly tape, and it's in a tennis canister. And so it's clearly not a pay-for sort of project. But it's for a conference presentation, and it's sort of my test thing, so I can show people. So yeah, I did that off hours, and my conference presentation is sort of off hours, but that is sort of advertising for the business and all that.
Yeah.
But I don't, on average, do much technical work that I don't get paid for.
Yeah.
And I don't want to be one of these people that is pressuring other people. If you want to get a dev kit and you want to play with it, you want to learn Raspberry Pi, your son is actually going to be programming soon. Maybe it's time for you to start Scratch in the next 18 months before he learns how to type.
No, just have Benjamin teach it to you. I mean, that's
yeah, exactly.
Yeah.
But there shouldn't be a huge pressure. You should learn what you want to learn.
Yeah. Really early in my career, when I started at Deca, I thought, okay, I go home, I'm going to work on this thing, and I work hard all day long. I mean, I'm really focused on like whatever I'm working on. And I come home, I'm like, I just don't want to, like, yeah, I would surf the net. That net was early, but I would surf the web. I'd be reading things. I'd be doing these things. It's just like, I don't want to be thinking about how do I turn on this GPIO pin in order to turn this thing on. And now I don't want to do that at home.
Well, and it's hard for me too, because unless you have something you really want to make.
Yes.
That's the other thing.
It's like, well, I want to learn this, but
it's
impossible to learn something if you don't have a goal in mind.
Yeah, and that's the other thing too. I'm like, far enough in my career, like I have a certain number of hours per day. I make a certain amount of money. I can trade those 2 things off.
Yeah.
So if I need this thing to light up the room when we turn the lights off, well, I'm gonna go buy a nightlight. that's I'm gonna spend a few dollars and be done with it. Like, and not have some photo sensor that I read and then I turn on LEDs in order to do a certain pattern. I'm like, I just really want a light on. Okay, I'm gonna go buy a $5 nightlight.
And yet, if your son said, I want a nightlight that is purple and lights up a dragon, you might at that point take that opportunity to think, okay, yeah, I can show him that I can do this.
Yeah, well, that's also, that would be a goal.
It would be a goal.
He would ask me for it. So
yes.
I don't personally want to light up Purple Dragon right now, so I'm not going to make that.
It's easier if you have a goal.
The little guy asked me.
Somebody else.
Yeah.
And most of my little home projects, I wore my ring to your birthday party where that gives, when you tap it, it gives you a new word. And I did that for myself because I wanted to learn the micro view, but also I had a goal. There were a couple of parties I was going to go to.
Yeah.
I know that I'm awkward at parties. I know that the words would crack me up, even if.
And you were between contracts.
And I was between contracts, so I had time. I wasn't doing it after putting in 8 hours at a job.
Yeah.
I don't know. I just kind of wanted to make sure people
It's not
heard
bad
that it's
for
okay.
people. Yeah,
it's okay either way.
No, I think it's great. And actually, truthfully, I'm jealous of that. Like people have
me too.
that drive because, like, I've just have the idea and go home and do it. I used to work with a guy who he'd come home. He'd come in on Monday. I'm like, what'd you do over the weekend? He's like, I made a satellite receiver out of measuring tape. I'm like, what? This is a thing? He's like, yeah. And you cut it to a certain length and you use measuring tape because it already has the measurements on there. I'm like, okay, that's really awesome. I mean, like receive like NOAA data signal, National Oceanographic Weather information, and like with his measuring tape satellite dish. I'm like, okay, that is really cool. But that's not something I'm going to go home next weekend and work on. I'm going to go over to your house. I'm going to check it out.
Yeah,
Yeah, exactly.
It's amazing. And when I hear people who do that and like just they're hitting out, like, am I just not as efficient as them, or are they just, did they drink way more caffeine? Like I don't drink coffee, so like maybe I should drink coffee. And
I recently started drinking coffee. I haven't done any. Yeah, well, I do more music.
Oh, it's like when I was actually back to the goal thing. Like I used to play. I played trumpet all through school, all through college, and I played a few years after, and then I stopped meeting the people that play. Like if I didn't have a concert I was practicing for or a gig that was coming up, like I didn't play. So I think it's the same thing. It's like I don't have something going in that direction. I'm like, I'm gonna go work on. I'm gonna go do something else.
Well, my brain gets tired. I mean, it gets tired in different ways.
Yeah.
If I had to spend the whole day at work reading, then maybe after work I might code. Or when I was a manager, I was more likely to code after work.
Yeah.
But when I'm coding at work, I want to go home and I want to do something different.
Yeah.
Something.
Well, I think you have to reset.
Yeah.
To,
and different
let your
coding
brain
isn't
relax.
enough reset for me.
Yeah. Yeah.
That's where spy novels and
Yeah.
fantasy novels and mystery novels.
Yeah.
And
Yeah.
all the novels. All
Yeah.
the books.
Yeah. Yes. I do worry about that with some people who are always making, and I'm sure people can do it, but like you got to have that downtime to let things soak back in order to get back up to a good level, like at work.
And when I do have the time and inclination to make stuff, it does help my work. So I think you shouldn't like forbid it because
Yeah.
it is very useful.
Oh yeah, totally.
But I don't think that it is required. And I don't think we should make it an industry requirement that we're on 24 hours a day and we only get paid for 8 of them.
That's a whole other conversation right there.
And how do you feel about open offices?
Well, but that's what Cisco was like when I first started working there a long time ago.
Yeah, which time? There were like
The first time,
3.
right out of college. And, I'd go there and I'd work and then I'd go home. And then I'd come in the next day and somebody would say, well, I went home and I had dinner and then spent a half an hour with my wife. And then, I coded until 2 a.m. and I made this. And they would do that like every day. It was just like they'd get up in the morning, they'd come to Cisco, they'd code at the office, then they'd go home and then they'd, eat and then they'd code until they fell asleep. And those weren't even make projects. That was just we're just working on that, and it was a big company. It wasn't a startup. It wasn't like, oh my god, if we don't get this done, we're all gonna be looking for new jobs. And that's a kind of passion that I respect, but I just couldn't make sense of it.
Yeah,
and
I mean, and the other thing too is like when I work at a place and I'm working on a project, I think about it probably an unhealthy amount.
Yeah,
like. That's like, again, on my train commutes, I would solve a lot of problems on the train because I had a laptop, but I just wouldn't open it. I would stare and I'd be reading something or looking out the window. I'm like, that's how we're going to do that.
You mean actually thinking about a problem?
Yeah, it happens sometimes.
Instead of just typing at it?
Yeah, it happens sometimes.
That works.
But like at my current gig, I go home and I'm still thinking about, okay, how can we make all this better? How can we make it all work? And I think about it all the time. So it's kind
And
of
so you can
unfortunate.
do a lot of stuff without fingers to keyboard.
Yeah.
And
So-
I think the making parts of it, you can do a lot without fingers to keyboard there
Yeah.
too.
Yeah.
And you don't have to build things.
Yes.
You can just think up something and then make somebody else do it.
That's when you become a tech lead or a manager.
Hey, I had this idea last night in the shower. I think you should implement it.
Open offices are the great lie of our century, of our time.
I think that's for another show.